All right, this is 8-1, Chapter 8, first section, solved by graphing. Today we're looking at a system of equations, which is two or more equations involving the same variables. When we have, when we have two lines, I know that before I said to you guys, I don't want to see more than one line per graph. But with a system, it could be two or three. They have a relationship. Those three should be on the graph. So it would look something like this. They would give you two equations, and they would say solve the system. And if they say solve the system by graphing, here's what you would do. We have two equations up there. So the first thing we're going to do is separate them. Let's look at the first equation by itself, and then the other equation by itself. So what do I need to graph a linear equation? Yeah. A slope and a y-intercept. So what is that, Journey? What? But what is the slope and the y-intercept for this equation?
Oh, for this equation? Well, the slope would be the y-intercept.
Okay, the slope would be what? 2 over, okay, and the y-intercept would be -1. What variables do I use for those? Burke?
You use M and B.
M and B. So I want you to always, that's always the first step. That is the work required for graphing a linear equation using the slope-intercept method. You have to identify M equals 2 over 1 and MB equals -1. And turn that M into a slope. Put it over 1. Okay, so where's my starting point once I graph? Dixie?
-1.
I start at -1. And then what am I going to do, Brent?
Go up 2 and then to the right 1.
I'm going to rise 2. Rise 2.
Rise 2 and run 1.
Rise 2 and run 1. And rise 2 and run 1. And what else could I do? What else could I do? How about Dixie?
You can rise -2.
-2 over,
1.
nope, over -1, because a negative divided by a negative. So I go down 2, left 1. This is negative, and this is negative direction. Down 2, -1. And then I plot those points. And I draw a line through it. So now I am going to draw my line and run the line through it. Questions on that? Now we're going to do the same thing for the other equation. They're just giving us two equations. What do I need to do to graph that, Catherine? Okay, so what am I going to do? Good. Subtract x, and my new equation is y equals -x plus 5. Let's go with Kiana. Next step.
Get the M and B, the y-intercept and the slope.
Okay, and what is that?
The slope would be -1 over 1.
And the...
And the y-intercept would be 5.
Okay, what am I going to call those? One more time. Say it with the variables.
The M
Equals
-1 over 1.
and
Would be 5.
B equals 5. Okay, starting point, Rebecca.
The starting point would be 5.
Okay, on the y-axis. And now what am I going to do? What am I going to do? Yes.
You're going to rise
Rise -1, run +1. So that would be down 1, +1. Down 1, +1. Down 1, +1. And then I draw my line through it. Grant, what is the solution to this system?
The intersection,
The intersection is the solution.
which would be 2, 3
1, 2, up, 1, 2, 3. You put the address, the ordered pair, the coordinate. 2, 3. So 2, 3 is the solution to the system. So when we have systems, there's 3 things that can happen. Okay? The first is hold on, my dossier's zoning out. Okay, the first thing is just when I need it. Okay. Whew. It says drawing mode. Just going a little slow today. It went from sending to drawing mode. All right, so the first situation is where they intersect. And in that situation, there's one solution. The second one, I wish I could write this, is when they're parallel. When 2 lines are parallel, how many times do they intersect? 0 times. So how many solutions are they going to have, Grant?
No solutions.
No solutions.
All set.
Okay? There will be no solutions when they're parallel. Now I can't draw here because it's not allowing me to send. So, one more time, they said there's 3 possible things that can happen. The 2 lines can intersect, and you have 1 point of intersection. That's one solution. The lines can be parallel. That means the lines have not intersected. Thus, that means there are no solutions. And then the last is when the 2 lines are on top of each other, means there's an infinite amount of solutions. So, 2, 3 is the solution. It's the solution to the system. Questions? Yes. Right now, we're not even working on perpendicular. To make it perpendicular, actually, what do we need to have a line be perpendicular? Not the exact reciprocal, the opposite reciprocal. To be perpendicular, it must be opposite reciprocal, and you take a point from the line. Any point from the perpendicular line. You need a point on the line and the opposite reciprocal slope. To be parallel, it would be same slope. But here, we're graphing 2 lines and we're listing the solution. The solution is the point of intersection. All right, so with that in mind, why don't you try these next 2 on your own? Pause the recording, and you're going to graph the 2 lines and tell me the solution. So, what do I need to do first? Mary. Subtract x from both sides. Get it into slope intercept. Okay.
And you have to find that M and B.
Identify the M and the B. And what is the M?
F is negative 1 over 1. And B is negative.
Okay. And where's my starting point, please? Jazz.
Negative 1.
I start -1 where? On the y-axis. Okay, you're being tested this year 3 times in Common Core. If you can't name that, you will score below basic. Okay, you've got to be able to use the language that supports it, not just be able to do it. So, because the testing is going to pick up those words. You're going to get extra points for academic language. Okay, now what am I going to do next, Alexander?
So you're going to go up. Oh wait, go down 1.
Math language, please.
Sorry. Move. Go down 1 on the y.
What do we call this?
Rise. Oh, rise. -1 on the y-axis.
Okay, so we're going to go down 1, rise -1, and then,
And then run 1 on the x-axis.
and what that would be? To the right or to the left?
To the right.
Good. And I'm going to do that a couple of times. I'm going to rise down -1 and then run right 1. That makes a negative divided by a positive is a negative. And I'm going to do that a couple times. And when I have no more places to go, which way am I going to go now? Brent.
You're gonna
Rise
rise +1, run -1.
+1, run -1. Rise +1, run negative. And I'm going to draw the line. Next step. Yeah.
Now you're going to go to the second equation.
Now I go to the second equation.
So you're supposed to put it in slope-intercept form.
I'm supposed to put this in slope-intercept form.
So you're supposed to add x on both sides.
And now I'm going to add x to both sides using which property? Yes.
Property equality.
Yep. Addition property of equality right there. And what's left, Evan?
2y equals x plus 4.
2y equals x plus 4. Next step, please. Cynthia.
And so you have to
Nobody can hear you. What? Divide -2 to what? Divide 2 on both sides. Finish the sentence. Of the equation. Thank you. You could also, to use academic words, can anybody think of anything else? Brent. We can use the division property of equality. Divide all, how about terms by 2? Good. Again, remember like when you're writing an essay? You know how you're writing an essay and like you finish drafting it? I do this with my son. Maybe your parents don't because they're not teachers. And then I'm left with y equals, wait, what's this next? Yes. I need to hear you what?
y equals half x
1/2 x
plus 2.
plus 2. All right. You know how this is good for you too, Shai and Jacob in the back. Jake, Allen's. With the core testing, you know how when you write an essay, afterwards you're done, you're like, okay, where can I substitute some good vocabulary in here to really impress my teacher and make them think that I'm really smart? So you put in those fancy words. We call that academic language. You do that here too. Because when you're answering questions, the more academic language you use, the more points you get. So by saying, I'm going to use the division property of equality, divide all terms by 2, that's 2 academic words in there. And speaking in complete sentences. You're going to start getting graded on that. Does that make sense?
Yes.
Okay. So, next, we end up with this. Where do I go next? How about Jenny? How do I graph that? Arya, we haven't done what we need to do. You're choosing to use slope-intercept, yet you're not doing the pieces that are required. Kiana.
You have to figure out the y-intercept and the slope.
Okay, you have to identify the y-intercept and the slope. And so what are they?
So m would equal 1/2.
M equals 1/2
And b equals 2.
and b equals 2. Okay, where are you starting?
On the 2.
On the 2 where? What, Kiana?
On the y-axis.
On the y-axis. And then I plot the point. And now from here, Flora.
So you go down 1 and across 2.
Okay.
And then when you have no space, you go up 1 and across 2.
To the right 2. Okay, you run 2. Okay. And what is my solution, Catherine?
The solution is 2, 1. X equals 2, -2, y equals
X equal, it's not X equals Y equals, it's an ordered pair. What is it?
-2, y.
-2, 1. Good. So the solution to the system is -2, 1. Questions? Okay. Also tonight, you will be asked to solve these. Tonight, you will be asked to figure out if this is a solution to the system algebraically. So what we do is we take each equation and we substitute in the point. So Boleyn, when I have 3x minus y equals 5, where does the point go?
So you substitute the x with the 2 and the y.
With the 1, I substitute them in. What do we get?
So then you multiply 3 and 2 and you get 6 minus 1 equals 5.
Okay, and 6 minus 1 is what?
5.
5 equals 5? So is that a solution? When they're equivalent on both sides, if it works and makes both sides equivalent, that means it is a solution to that. Am I done, Grant?
With there, no, you have to do the other one just to
You have
see
to...
if it works for both, because if it doesn't, it's still wrong.
Right, correct. So we have to see if it works for the other equation as well. Substitute in, and I get 4 plus 1 is what? Is 5 equal to 10? So is this a solution to the system? No. This is a solution to this equation, but not to the system. And that's the question. Determine whether the point is a solution to the system, not the equation. So the answer would be not a solution. 2, 1 is not a solution. Questions? Okay, pause the recording and you do number 2. So let's continue. What am I doing first, Jenny? How's the new line going to read? Times. Perfect. And so when I do that, what does it simplify to, Byron? I can't hear you, I'm sorry. And what does that equal? So 7 equals 7. Is that a true statement? Okay. Next one, I'm going to do the same thing. Substitute in. Flora, does it work?
Yes.
Because, read me the next line.
Because negative 6 is equal to negative 6.
So is it true or false?
True.
Okay, and what statement do you make about this afterwards?
4, negative 1 is the solution to this equation.
Okay, 4, negative 1 is the solution. Is a solution. Now, really quick, I'm just going to remind you, whenever we're doing this, when you're graphing, there are 3 types of situations that occur. The first is when you have, oh, here we go again, getting slow. The first is when you have 2 lines that intersect. What happens there? What do we call that? How many solutions are there? How many solutions? Aiden? 1 solution. And we have, how about parallel lines? How many solutions do we have? Nick Costa? Okay. Infinity? 2 parallel lines like this. How many points of intersection do we have? 0. No solution. Okay, then we have 2 lines that are on top of each other. Something like this. Like y equals 2x plus 3, or 2y equals 4x plus 6. It's not really a big enough graph. One, 2. Okay. And I'm rising up. Oops. It should have been 3. I'm going to go down 1, 2, over 1, 2. Something like this, where that is y equals 2x plus 3, and when I get 2y alone, look what I end up with. Y equals 2x plus 3. It's really the same line. So it's 2 lines on top of each other. How many points of intersection do they have? Urani? Infinite. So this is the same line, or, oops, 2 lines on top of each other. This is infinite. Okay, questions? All right, let's try one more. Just taking so slow. Okay, try the next 2. Go. And this time, are we solving algebraically or solving by graphing? They provide the graph. It's not a very accurate way to graph. Because if you get fractions, you can't really eyeball that. There's no way to...
Get it perfect.
Correct. Okay, you guys can stop the recording.